All right. Good afternoon, everyone. Thanks for coming. I know you have a lot of choices of different sessions, and you chose this one. Thank you for that. I hope this is worth your time over here. The topic of my presentation is, why do I need Kubernetes when I already have Cloud Foundry? Someone mentioned it's a little provocative topic, so hopefully this will be interesting, and it will hopefully clarify this question to many of you. How many of you are familiar or heard of Cloud Foundry, by the way? Okay, pretty much most of the room, so that is fantastic. First of all, I'm Sanjay Patil, product manager at SAP, working in SAP Cloud Platform. I work from Palo Alto office in California. I have been in the tech industry for close to, I guess, a couple of decades now. I have worked on different products, platform technologies, application server, integration broker, middleware like Corba, B2B, web services, lots of gray hair. My friends were telling me that I had thick black hair until I started looking into cloud technologies. It's just too much, and the hair started turning gray. Today, I'm going to talk about how these two things come together. This is not a product talk, obviously, from SAP, but we wanted to share the thinking within SAP at this point of time about how these two technologies relate to SAP and probably to most of you. This is how I'm structuring my talk. First of all, I would like to talk about Cloud Foundry application runtime. What are the target scenarios? SAP has been the foundational member of Cloud Foundry Foundation. We have been part of the foundation right from its inception. There are many SAP engineers making contributions to Cloud Foundry open source code today. Cloud Foundry technology has been adopted within SAP solutions, in particular SAP Cloud Platform. So definitely we are one of the main supporters, leading contributors in the Cloud Foundry open source project. So I want to talk about what are the target scenarios for which we see value in Cloud Foundry and why we are heavily invested in Cloud Foundry technology. And then I want to talk about some of the cases where the Cloud Foundry paradigm really does not fit very well, where Kubernetes is the right answer, taking some concrete examples of SAP solutions that are leveraging Kubernetes today, so it becomes clear where we are using these two different stacks. And then I want to talk about open source project, Project Gardener, a new open source project initiated by SAP to make some of these Kubernetes adoption easier for SAP as well as our customers, because that's also essentially part of a vision we have at SAP to have Cloud Foundry and Kubernetes stack integrated together. So that's the general structure of my talk. So let me begin with a very short, quick overview of Cloud Foundry environment. So what you see right here at the center is the application. So application in Cloud Foundry could be developed using any programming language of your choice. Popular programming languages like Java, JavaScript, Ruby, Node, HTML, Python, Go, as well as you can use any other programming language of your choice by using the build pack mechanism in Cloud Foundry. It's fairly straightforward. And to expedite the innovation, most developers would use the backing services like PostgreSQL, RabbitMQ, some of these popular backing services, MongoDB, Redis, as well as in the case of SAP Cloud Platform, the SAP's flagship in-memory database engine, SAP HANA. And the platform obviously has some of the platform services like Autoscaler, logs management, job scheduler, and in most cases, you'll also need a service for security, user account and authentication, using which you'll connect the platform to your corporate ID provider. And in many cases, obviously, the cloud applications would need to access data and functionality. In lots of scenarios, the data and functionality resides on-premise systems, so you'll need a connector to access that. And lots of new cloud-native applications do want to leverage innovations in the area of IoT, machine learning, blockchain, so on and so forth. So there's a packaging of innovation services as part of the environment. And the entire Cloud Foundry environment itself runs on different public clouds like AWS, Azure, GCP, and many more. And this is not just a technical enablement, but the SAP Cloud Platform, Cloud Foundry environment actually runs as a platform on these different clouds. So you can build an application, pick and choose which cloud provider you want to deploy it on, and you can run that application over there. And then, of course, the additional things on this slide are some of the tooling to access the platform. So that's basically the bill of materials or what is included in a Cloud Foundry environment. So let me also spend a couple minutes to talk about the high-level architecture or the pattern of Cloud Foundry applications. So as I mentioned, the application using any build pack, that's really the heart and center of Cloud Foundry environment, Cloud Foundry platform. And then this application uses any of the backing services. So fundamentally, the application developer focuses on building the business logic in a programming language of his or her choice, right? And then the application developer would then specify the dependencies, like my application requires a certain messaging system, certain framework, certain library, and the application code is then pushed to the platform. It's a platform that looks into the application code, identifies what language it's written in if it's not already specified, looks into the list of dependencies, gets hold of those backing services, does the plumbing. First of all, it creates a droplet, a running instance of the application, does all the plumbing to have your application microservice talk to all the backing services, and takes care of managing health, scaling, and all the runtime. So the main idea or the main difference when compared to Kubernetes-based environment is that over here, the application developer experience is highly simplified. Application developer does not really worry about where my microservice is going to run. He or she would also specify some configurations about resource requirements, but most of the heavy lifting of managing the runtime processes, their scaling, that's done by the platform. Application developer simply focuses on writing the code. So in Cloud Foundry, you can actually push the code along with just a manifest of dependencies, and the Cloud Foundry environment takes care of realizing all the runtime processes and its health management. So having said that, this is certainly a very powerful model. We see this quite useful in many scenarios where, for example, a customer has several different projects going on in the IT, and the developers want to make different choices of backing services, programming languages, but at the same time, the customer also wants to have some kind of central governance, like what technologies are used. If there is a security patch that has to be applied to certain framework, instead of running around and finding out which projects are using that framework, it's better to apply it in one place and everybody benefits. So we definitely see value in that. And that's one of the main reasons why SAP has been supporting Cloud Foundry. However, as I said at the beginning, there are other scenarios where the Cloud Foundry CF push paradigm just does not fit very well. In particular, if the application developer wants to write not just the application code, but also include the additional libraries, additional frameworks as part of the same package. Again, this kind of breaks the separation of concern model, but there are scenarios where the developers know what they're doing, or at least they think they know what they're doing, and they need a control over building the entire package. And over there, a container model definitely comes very handy. Likewise, there are scenarios where, and again, this is a Kubernetes conference, so this is preaching the choir if I went too deep into these aspects, but just to list some of the main scenarios. There are cases where the developer wants to have the same application package that is built on his desktop, also running in testing, in development, in production, wherever that is run, right? So in Cloud Foundry as well, you could guarantee the same application package across the landscapes, but then you have to have some strict processes that would ensure that the overall configuration is same, right? Whereas with containers, it's pretty inherent that once the developer has program the container, then it's going to be the same image running anywhere. So for these scenarios, I think we all would agree that container native programming provides better assurances of having the same package running in different deployments. The next one is obviously one of the more important ones, which is cases where the developer needs greater freedom or greater control over the infrastructure, right? Cloud is pretty powerful, obviously. Cloud platforms do a lot of heavy lifting. But behind the scenes, in order to give a simpler experience to the developer, the cloud platform has to move a lot of things around. If there was a backing service that was running right next to the application at the beginning, over a period of time, the microservice might have shifted to completely different nodes, different hosts. So you cannot make many assumptions about how the cloud platform or platform as a service is going to arrange the topology of different parts of your overall application. This may work in many cases, but there are cases where this just would not work. Like, for example, if you have a machine learning application, in that case, the application obviously has to be deployed on specific hardware, right? Typically GPU servers. You cannot arbitrarily shut down an instance in one place and start on any other node. So binding the application to specific hardware, that shows up in like machine learning, blockchain, and many such scenarios. If the architecture of the application, particularly for multi-tenancy, that is assuming that there is a network of containers per tenant, then you need a certain detailed level of control over how your application process instances are grouped together and how they are associated with specific tenants. Likewise, there are cases where different processes must be clubbed together because they have certain affinity. There are cases where process instances should not be running together. So for all these reasons, you would need greater control over the underlying infrastructure. Also, to support resiliency and high availability, in many cases, you cannot just depend upon the platform. Based on the specific application requirements, you need to get down into the details of how do you want to actually materialize high availability. So for many of the scenarios I just talked about, containerization obviously is the main solution. And for orchestration, Kubernetes is the platform that we are going with. I'm not going to speak much on this slide. As I said, this is the Kubernetes conference over here. But only thing that I want to point out is this whole idea of having a container instance consuming compute, storage, networking, that's pretty common. That has been around for a long time. But with Kubernetes now having this entire metadata that is associated with the containers, the configuration of the containers, the networking policies that would decide which container can talk to which another container, having, for example, replica sets that would allow you to plan out your custom resiliency and high availability. Having deployments that will use the metadata and allow you to have rolling upgrades of your entire application, or pause an application, or go back to a previous instance of an application. All these powerful capabilities that are introduced by this metadata layer on top of these containers, that is pretty powerful, and that has been utilized heavily. So I want to give you some examples of SAP's own projects where containerization and Kubernetes as an orchestrator has been heavily used. One of the main ones is SAP Data Hub. So the problem over here is in most customer scenarios, there are different data sources, different data systems, and most business users want to have applications that consume data from all these different systems pretty quickly, right? So this is an age-old problem. How do you get data from different systems together? And we have been talking about this over many, many years. And still the problem remains to be not completely solved, if not unsolved, right? So what's the fundamental issue over here? The issue is that it will always continue to be the case that there are different data systems and data sources, right? You cannot realistically bring all this data in one place. So we need a solution that would allow the data to sit where it is and still allow communication between these different data silos and realize the application's requirement. So the main idea that SAP Data Hub brings to the table is to have these powerful pipelines of data processing, and these pipelines are pushed down to the nodes that are running close to the data systems. So the idea here is to have, so what's a pipeline? Pipeline is essentially a computational graph, which is a network of operators. So as I mentioned, there could be data systems, big data stores, traditional databases. So the operators are essentially processing data that is specific to that data system. Now you can imagine some operators sitting close to the big data system, another operator sitting close to your cloud storage system, and a higher level application that has this overall data flow is then executed by having these containers that are running close to these data sources. Now, in order to have these container instances talking to these different systems, you might use different libraries, maybe different binaries, and customize these operators in ways specific to those data systems. There may also be cases that certain nodes in this data flow that need to be run on the same host, or you might want to separate them. So for these kind of scenarios, having a containerized architecture and orchestration via Kubernetes comes extremely handy. Blockchain is another example. where having specific hardware behind the scenes is overall fairly commonly required. And in this case, we're also looking into using different Kubernetes clusters for different tenants, pretty handy model that's been used by this team. SAP Concur. Now, the previous two examples I talked about, one was about SAP Data Hub, which in my opinion is more quasi-platform that's providing a certain level of platform for database applications. The other example of blockchain or machine learning, these are more backing services using which then you build applications. SAP Concur, on the other hand, is an application. It's an application for travel expense and invoice management, which is used by millions of people on the road, and they expect this application to be always available, right, from wherever they are. And the application has been around for a long time. And now it's going through the process of modernizing so that it can even meet the needs of increasing scale requirements. And in order to do that, this team looked into different options. So options for a platform that would allow the transformation in a phased manner. For that, they found the extensibility of Kubernetes to be extremely powerful. So we have already been using Kubernetes. So if you are in the keynote today, there was a slide on end users using Kubernetes in production today. This was one of the solutions. This team found the setup time for Kubernetes to be extremely manageable or better compared to other platforms, as well as the fact that the Kubernetes orchestration is not tied to a specific container technology. That was also an important deciding factor for this particular project. Over 30 services in this long list of services as part of the SAP Concur application currently do use Kubernetes, and the rest of them are in the process of being modified to use containers. So again, I think these few examples gives you a flavor of different projects, like with different SAP solutions using Kubernetes today, SAP Data Hub as a quasi-platform, machine learning, blockchain as backing services, SAP Concur as another example. We have colleagues from other teams as well over here, SAP Hybris. They have been using Kubernetes for quite some time as well. So here is a list of few of the projects. Some are services, some are applications. And there are obviously projects from our customers and partners who have very similar requirements. So for all of this, what we really need is Kubernetes cluster as a service solution that is A, secure and scalable, right? Like for example, if a team is using Kubernetes for their project, then they would want to create a cluster, do some development, create another cluster for testing, multiple times testing. So instead of maintaining a cluster all along, they might want to spin different instances at different periods of time in the development phase. And all of this has to be extremely easy, right? If the setup time is much higher, then it's getting in your way of continuous integration, continuous delivery concepts. For our customers, having a solution that works homogeneously across the public clouds and on-premise so that they can easily create Kubernetes clusters, cluster as a service on these different public clouds is very critical so that they can expand their business into any markets that they would like to, because they can easily start a cluster in a public cloud in that different region, have a cluster running on top of that, and have their solutions deployed on top of that. And all of this has to be done with minimal TCO. That's really an important point, right? Lots of open source toolings out there, they would let you get the system up and running, but for day two operations, it's not always straightforward. So we actually looked at several options to provide and operate Kubernetes. As I was mentioning, in the community, there are lots of tools. Many of them are, frankly speaking, still developer focused. They have either limited or no support for day two, and we didn't find them to handle thousands of clusters, which is the case in the case of SAP. The commercial tools that we looked at, they aim to fill the gaps in the community tools, but then there's a risk of having a vendor lock-in, and in general, the time to market was fairly high by having those commercial tools work with the solutions that we needed. Hypercloud providers, obviously they have solutions for cluster as a service, and obviously we work with all of these partners, but what we wanted to have is a simple cluster as a service that is independent of the different cloud providers, so that our development teams don't have to have separate plans for testing their solution with cloud provider A and have another testing for cloud provider B, we wanted to have a model where they test their solution on Kubernetes cluster once, and it should run uniformly on any public cloud, as well as in the on-premise systems set up using OpenStack, VMware, what have you. So for these reasons, what SAP started is a project Gardener, which is currently open source, github.com/Gardener. Please do check out. And if you like it, please start it as well. So this is launched by SAP, gaining community support fairly faster. The main promise is to be able to create and manage Kubernetes clusters on any cloud or on-premise with just a simple single click of your mouse. It is extensible, as most things in Kubernetes. You can add new features. You can add support for new cloud providers as well. And one of the unique aspects of this project is it uses Kubernetes itself for automated health management and scaling of the control planes. And I'll talk about that shortly over here. So if you look at the main idea of this project over here, in a traditional Kubernetes cluster setup, you have the master nodes, which host the control plane, and worker nodes, which actually manage your workloads, right? And if you have multiples of these clusters across the globe, then initially to get them set up and get them going is well and good, but how are we actually going to keep all of these clusters in sync? Right? Maintaining all the control planes on these different clusters is not a trivial task, to say the at least. So the implementation approach in Gardener is that the clusters that are actually running the workload, we take out the control planes of those clusters and make those control planes as the workload of dedicated Kubernetes clusters. So the idea here is to have shoot clusters. The concept of seed and shoot is coming from like the botanical word. So you have the seeds that will sprout different shoots. The shoot clusters are the ones that are running only worker nodes, and their control planes are running in the seed cluster. And then I can quickly give a demo of the Gardener project over here. May the demo gods be with me rather. So this is a simple, fairly straightforward demo, and this is again something that has been used in SAP by several different teams. So this is the Gardener dashboard over here. As you can see, there are, so walking at these menu options from bottom to up, there are administration controls to some administration setup. Members, I'll skip that. Oh, sorry, I'm sorry. So there is nothing, so that is not good. Exit the presentation, okay. All right, sorry about that. Okay, so this is the Gardener dashboard. And so there are many options for administration members. And if you look at the secrets, here you can obviously configure your secrets for different cloud providers. Currently, Amazon Web Services is what I configured for our demo. We are currently prepared to deploy clusters as a service on Azure Cloud, GCP, OpenStack, Ali, and there are more cloud provider as well as on-premise solutions that are becoming available shortly. So to create clusters is fairly straightforward. So for example, I have a few clusters running over here already. The interface for creating new clusters would look something like this. You can obviously provide the cluster name, pick the infrastructure, public cloud provider that you're interested in. For this demo, AWS is what I'm going with. You can pick a specific region, also pick a specific version of Kubernetes that you're interested in. And for the cloud provider, you can go deep down and go to the next level and also pick the zone that you're interested in and the purpose for which you want to have this cluster created. Interestingly, you can also get into the details of setting up the node pools. Like for example, if you wanted to add different node pools, if you're not happy with the machine types in that node pool, if you needed more powerful machines hosts in that particular pool, you can configure them over here. In addition, you can also configure different operating systems right? Like if you go with any specific cloud provider's cluster as a service solution, you have a limited set of operating systems and a limited set of other choices. But over here, we have much, much wider option of all of these configurations for the node pools. So with that, you could create these. You can have different add-ons. You can also configure the maintenance schedule for your clusters, whether you want the patches to be applied automatically or not. So in the interest of time, I'll go into one of these clusters that I just set up before getting on stage over here. So over here, this is a cluster that has been created, and the cluster creation should take you less than a few minutes. In fact, I created a cluster when I was on the way from airport to my hotel room from my mobile phone. It should work from your phone as well. I mean, there's no big deal over there. But if someone needs to do that, you could do that. So this is the kube config here. The main point I would like to draw your attention to is this is perfectly standard kube config, right? So if this from a command prompt, if I were to look at the kubectl config view, you can use the standard tooling to manage your cluster from any of your tooling or from the dashboard as well, because we're using the totally standard configuration and other mechanisms over here. So I believe this is slightly slow, or as usual, the demos always have slight glitches, but we'll come back to that. Meanwhile, let me show you the dashboard. So from over here, you can directly go to the dashboard of that cluster. And this should be the familiar Kubernetes dashboard that you would see for managing any clusters. Over here, I just deployed a workload for a simple workload with 5 instances, five pods over here. You can get into parts as well as, for example, replica sets. And for any given replica set over here, right from over here, then you can scale that to have multiple number of parts as you need it. You can also edit the replica set, which is typically not what you might do. You might actually want to edit the deployment, but just to make the point over here, you can make the changes to the specification over here. And then just by having a submit or apply button, the Kubernetes would take care of bringing the state of your cluster to the specification that you just made over here. And so I think this is the command I had issued. So this specific kubectl config over here and what you would see from the command prompt, they're exactly same. And I could use any other kubectl commands over here, like for example, get the parts for my Hello Web application that I just deployed. For some reason, this is slightly slower than normal over here. But I guess this makes the point of having a single view for creating clusters on any cloud provider that you would like, and whether it's on-premise or in cloud. So with that, let me shift the gears and bring me back to the presentation. All right, so that was the demo. And as far as architecture is concerned, as I was mentioning, there is the concept of using Kubernetes itself to manage the control planes of your actual clusters that are running the workload. So this first cluster that we spin off is the garden cluster, which is kind of the central cluster, from which then you would access the different target infrastructure as a service options. So for each target IS option, you would then first spin off a single seed cluster. So this seed cluster will then have the different controllers that would be used for managing your actual shoot clusters which run the workload. So with that as the main innovation happening at SAP, which is now open sourced, again, please do check out on github.com/Gartner. The question then remains is, how do all these things fit together, right? So we have different SAP projects as well as customers and partners using or wanting to use Kubernetes. And we have the cluster as a service solution coming along. SAP as a strong supporter of Cloud Foundry. We have a Cloud Foundry-based PaaS offering for the simplified development experience for agile innovation. So how do these things fit together? So as I just mentioned, for agile innovation, we have Cloud Foundry environment. We always start with multi-cloud as the main starting point. And then there's Cloud Foundry environment running on these different cloud environments. You would then create services, either directly running on any of these infrastructures or from elsewhere, and you would bring those services for consumption in the Cloud Foundry environment, and you would build the apps using Cloud Foundry. So this is the current status, right? So you have Cloud Foundry as a PaaS solution that's running on these different multi-cloud options. And the Cloud Foundry platform is creating apps. Those are consuming services. Works beautifully for agile innovation scenarios, 12-factor apps, stateless apps. These cannot typically be the complex applications like SAP Concur. But for those scenarios where 12-factor apps is the choice to be made, Cloud Foundry works beautifully. For Kubernetes environment, as I listed some of the different types of workloads, like the Data Hub, blockchain as a service, or SAP Concur and other applications. Or here again, multi-cloud is our main concept in all of these offerings. And then use Kubernetes with open source Gardener as a project to create and manage clusters in a simplified and easier manner. And then you would build services on top as well as applications. So this is how the Kubernetes world is handling problems and the different types of workloads at SAP and in our ecosystem. Going forward, however, we have a vision where, again, starting with multi-cloud and having Gardener provide Kubernetes cluster as a service offering and providing solutions, environment for creating services and apps, what we would also like to say is the Cloud Foundry itself is running on top of Kubernetes. And so that Cloud Foundry becomes available wherever Kubernetes is available from an SAP standpoint. And then the apps that are created on top of Cloud Foundry, they would also run as Kubernetes cluster workloads. So the main idea over here is that today, those teams which started with using Cloud Foundry environment as the platform at the beginning, and when the applications outgrew, and they needed to get into the lower level infrastructure as a service and started building some Kubernetes-based solutions. These are the same teams which are handling both 12-factor apps as well as the stateful apps. So when these teams have to make the offering in a totally different region, they have to start worrying about how do I get my Cloud Foundry platform set up? How do I get my cluster for the backing services set up? So by having Kubernetes as the underlying fabric and running both Kubernetes workloads as well as the entire Cloud Foundry platform as a workload on Kubernetes, it becomes much more simpler, both from the developer experience as well as from the operational efficiency point of view for SAP as well. So in this regard, SAP has been driving a bunch of integration projects. Some of them are taking place under the Cloud Foundry Foundation to start with cross-consuming services from Cloud Foundry, from Kubernetes apps or services in Kubernetes from Cloud Foundry apps, and to start with using, for example, Kubernetes scheduler for the Cloud Foundry apps to begin with, and then containerize the entire Cloud Foundry platform and run it as a workload on Kubernetes. So lots of open source activities, both over here as well as in the Cloud Foundry Foundation. So that was pretty much my last slide. Hope that gives you an idea of how SAP is looking at both of these platforms and our vision to bring these two things together. Thank you. So in the last couple of minutes, happy to take any questions you may have. Yep.
My question goes to Gartner, whether it also supports creating Kubernetes clusters with RBAC enabled, like role-based access control. Is that something?
Yeah, so we actually have some of the main product team members as well here. Yeah, so the question is, will the clusters created using Gardener also support security with role-based access control? And the answer is yes. And this is also one of the important points that I would like to make is the seed cluster that I mentioned that is running inside a target infrastructure as a service, that's essentially opening up the normal endpoints of Kubernetes for accessing the API server. So you might have your other management cluster running elsewhere, and now the seed cluster provides role-based access to your management cluster running elsewhere. This becomes an extremely important quality in cases where you cannot really directly access the infrastructure in the target IS because of the geopolitical or other reasons, or if the infrastructure is running on-premise, you just do not open these endpoints. So this is a role-based access control mechanism used for implementation of Gartner itself. Obviously, this is also available for the workloads that will be running in the Shoot clusters.
I have another question, if I may.
Sure.
Quickly. Is there a plan to extend the Gartner later on to provide something like a marketplace, for example, whether, like, let's say, ready-to-consume stacks are available, something like what the pivoted Cloud Foundry, for example, provides, or something like that? Or is it just will stop on the fact that, yeah, okay, I can create Kubernetes clusters anywhere, and that's the mission from Gartner?
So the question is Gartner limited to providing only cluster as a service, or would it enable to an ecosystem of solutions that could be used by all the users, if I may rephrase your questions?
Yeah, something like providing a marketplace where developers, for example,
Yeah.
can, let's say, install the ELK stack or something like that.
So will it lead to something like a marketplace where other services and solutions will become available? And the answer is absolutely yes. And that's one of the fundamental ideas that when this ecosystem grows, if you look at this model of garden cluster, seed cluster, and shoot cluster, as I was pointing out, just to take an example, there may be cases where a customer might be interested in using a certain operating system that is originally not part of our solution. So that will become available, that can be made available by a partner coming into play at the lowest level. Likewise, then you can build additional extension, Kubernetes extensions for higher levels of extensions as well. So it can essentially lead to an iTunes-like model where this just becomes a platform for creating cluster as a service, and then the partners and others can bring their solutions and create a marketplace for cross-usage. All right. Any last question? I think otherwise we are towards the end of this time of this session. Thank you so much for coming.